we are going to find domain and range, and I am just going to write all over this thing. So I'm not going to do all of these because we're going to do some of them in class, but here we go. I want to know what the domain of this is. So looking at this, the domain is going to be all of the x values that you're allowed to use. There are an infinite number of points between my ending points. So what you're going to tell me for the domain is how far left does this thing go and how far right does this thing go. So looking, all of my x values are from -5 to +3. So I'm allowed to use the -5 because it's got a closed circle. So I'm going to use a hard bracket. And then all these x values, all these x values, all these x values. There's an infinite number of them until I get to 3. That's why I can't just list it off. I can't say -5, -4, -3, because there's an infinite number of points between those. So I'm going to come all the way up to 3. I cannot touch the 3, so approach but do not touch. So he gets a soft bracket. So that's my domain. What's my range? For your range, you need to go from bottom to top. So what's the lowest that this thing goes to? And what's the tallest that this thing goes to? So he's going to bottom out at 0. And there are points there. Or there's a point there. Okay. There is a point at 0. And I've got all these y coordinates I can plot. All these y coordinates that I can plot until I come up to a y coordinate of 2. And I can use the 2. I can use it here. I cannot use it there. But I can use it. Okay. So what is my bottom? My bottom value for range is going to be from 0, and my top value for range is going to be to 2. So my range is all the y's between 0 and 2. Okay, so let's do this one. I have the domain. Well, what is my domain? So again, how far left does it go, and how far right does it go? So when I look at this, the furthest left it can go is -4. So it's going to start at -4 and it's going to go forever to the right. So my domain, I can touch the -4 because it's a filled in circle. And then I got all these x values for the rest of its life. So my domain is from -4 to +infinity. Now what's my range? There's an infinite number of points on this thing. So where does it bottom out at? It bottoms out at a y value of -2. And then this is going to keep going up for all eternity. Not only does it go right, it also goes up. Okay. So I've got it's bottoming out at -2. And then I got an infinite number of y values for the rest of its life. So my range has a low point of -2. And then it goes up for all eternity. Low point of -2. And then it goes up for all eternity. All right. So that's if we have a picture. What if we don't have a picture? So looking at the guided practice, I'm just going to walk through half of these with you. So I am given that f of x equals a -2 times x minus 1 times x minus 2. So this is in factored form. I know it's in factored form because it's a multiplication problem. I've got -2 times x minus 1 times x minus 2. Okay, so we are going to assume that our domain is all real numbers unless we see variables in denominators, unless we see variables under even roots. I don't see any variables in denominators. I don't see any variables under even roots. So my domain is all real numbers. Okay, what is my range? So let's think about this. If I shove in negative numbers, a -2 times a negative will be positive. This will go negative because a negative minus 1 is going to be negative, right? And then a negative minus 2 is going to go negative. So if I shove in negative numbers, what I have in the bigger picture is an x times an x times an x, which is an x cubed. Okay, so x cubed can spit out positives and negatives. Okay, so my range, because I can spit out positives and negatives, is going to be all real numbers. So let's try another one. we have f of x is going to be 5 minus 2x squared. So my domain, okay, my domain for functions is going to be all real numbers unless I see variables and denominators, unless I see variables under even roots. I don't see denominators with variables, and I don't see even roots. My domain is all real numbers. Okay, what's my range? So I need to look and see what I've got. Up here, this was in factored form. This is in polynomial form, so I can just look and say, okay, this is an x squared. So now we have to look and think about what our range is. Okay, what on God's green earth is our range? So when I look for my range, I want to see what the tallest number that x can be is and what the lowest number for x can be is. So recognize, regardless of what you shove in for x, it's going to go positive. Okay? Regardless of what you shove in for x, it's going to go positive. So a positive times a negative is negative. Okay? So you're going to be, if I look at just this part, a positive times a negative is negative. So I'm going to be taking 5 and subtracting numbers. 5 and subtracting numbers. So the biggest that this can be is a 5. If the biggest it can be is a 5, then the smallest it can be is somewhere in negative infinity. And I'm going to come up to 5, and it can equal 5. Okay, so the biggest it can be is a 5. So let's look at part C. Part C is going to be f of x equals the square root of x minus 2. And I would like to look at this, and I would like to find out what my domain is. My domain for functions is all real numbers unless I see variables under even roots, which I do. This is a square root. There's a 2 here that we're too lazy to write. Okay, so I got variables under even roots. I want to keep this thing positive because I don't want to go to imaginary number land. So my strategy is to grab the stuff under the radical, and the stuff under the radical is called the argument. Okay, so I'm going to grab this stuff under the radical, and I'm going to say, please stay positive so that I don't have to go to imaginary number land. But you can also be 0 because the square root of 0 is 0, so that's fair game. So now I'm going to add 2 to both sides. So x needs to be bigger than or equal to 2. So I'm going to have everything bigger than 2, but it can also be 2. So my domain is going to be starting at 2 and everything bigger. Starting at 2 and everything bigger. So let's see what happens with the range. So if you'll notice in front, your lead coefficient is positive. It's a positive 1. I'm just too lazy to write it. Okay? So my front number is positive. And then what types of numbers is this radical going to pop out? This radical is going to pop out positives because we just told it to. Okay? So we have a positive 1 times a positive radical is going to be all positives. So the only question, I'm not going to use negatives, but can I use anything else other than positives? So now, all positives, my question is, I can use 0. Okay, if I evaluate at 2, I get 2 minus 2 is 0, and the square root of 0 is 0, and 0 times anything is 0. So my range is going to include 0 and go positive. My range is going to include 0 and go positive. So for our last example, and then we'll cover the rest in class, we have f of x equals the cubed root of x minus 2. The cubed root of x minus 2. So when I'm looking for domain, I assume that my domain is all real numbers unless I see variables and denominators, which I don't, or variables under even roots. Well, this is an odd root. It's a cubed root. So my domain is all real numbers. Okay, so if I shove in negatives and subtract 2, I'm going to get negative answers. If I shove in positives and subtract 2, for the most part, I'll get positive answers. What happens if I shove in a 2? 2 minus 2 is 0, so 0 is also fair game. So all the negatives are possible, and all the positives are possible, and 0 is possible. So both my domain and range are all real numbers.